Okay, so this is the standard Fall 2015 Arduino kit that you'll be using for the next 3, 4, 5 weeks in ME30 for your labs and your homeworks. This is usually pretty much always the part of the course that students enjoy the most. So I hope you enjoy it as much as past students in past semesters have. So this semester, it's going to be a little bit different. There's actually 3 slightly different configurations, kit configurations for you to choose from that allow you to either save a couple bucks if you need to, or to spend a couple of extra bucks depending on what hardware you want to have to own in the longer term after you're done with this class. However, for the purposes of the lecture and the labs and the homeworks and stuff, any of the 3 kits is perfectly fine. There's actually not any huge differences between all the kits. So this demo is going to look very much the same regardless of what kit you're going to end up buying. So since you actually have to choose which one you're going to purchase next week or this week, if you didn't get on this video that quickly, I'm actually doing a separate video that describes the differences between the 3 kits. I don't really want to clutter up this introductory demo video with that information here. So go ahead and check that video out when you're done watching this one. Since all these videos are probably going to end up on YouTube, look for the other video or videos on the same YouTube channel. Anything pertaining directly to you in this semester will probably have Fall 2015 in its title. So focus on those. And if you see any other videos on the channel that you're interested in, feel free to go ahead and take a look. I don't think there's really that much out there right now. If the video isn't up there yet, it should be there in the next day and a half. Better yet, I think that you can just subscribe to the YouTube channel that this is on, and you should receive a notification whenever anything changes on the channel, new videos, new text. Not sure exactly, at least that's how I hope it works. So all 3 kits are composed of, well, the box, and this is a very sturdy box, I might add, and a stack of boards, and a bunch of other miscellaneous stuff which is in the bottom of the box, which I'll probably describe later. So of this 3-board stack that I've got here, let's try and zoom in a little bit on it, is it's essentially 3 boards. Here's the 3 boards, taken apart. So the first board is actually the Arduino board, and it's the bottom board in the stack. It is made by a Chinese board company called SaneSmart, and don't ask me what SaneSmart is supposed to mean or stand for, because I don't have a clue. However, this company makes pretty much the most popular Arduino clones out there from what I've been able to tell. A lot of the clones are kind of no names, and there's really only maybe 2 or 3 brands that have real names of real companies on them, and this is one of them. And as far as I can tell, this is one of the most popular ones. So we've actually been using these for 3 years or so, and we really haven't had any problems with them. So I don't anticipate you'll have any problems either. So let me first say that it's not a bad thing that we call these things clones, and these aren't the genuine Arduinos that the Arduino team makes. The Arduino team actually doesn't mind that companies clone the Arduino. They'd like to see people innovate and come up with new features and additional things that are globbed onto the Arduino, but sometimes they're just flat-out clones. The Arduino team from the very beginning always had the idea that this was going to be open source hardware, and the designs are free and open for people to do with whatever they want, and that includes making their own. And this company makes quite a few of them from what I can tell. What the Arduino team does mind if you do is call your clones Arduinos or use the actual Arduino logo on whatever boards you're making, or the advertising or the packaging or whatever. And they're actually really aggressive about going after companies that make or just sell clones that kind of try and make themselves appear like they're the genuine Arduinos, whether they're blurring that distinction intentionally or just through ignorance. So a lot of times if you see Arduino clones being sold on eBay, you might even see a photograph of the board that you're buying, but with what used to be the Arduino logo airbrushed out, because the Arduino team actually goes after sellers on eBay that misuse their logo. So what the Chinese do is they just airbrush it out, and that gets the Arduino team off their back. But I think by this time, probably none of the boards that are being sold have the logo and stuff on them. They've been harassing sellers on eBay for years about this, and I think pretty much everybody's figured it out that they shouldn't basically steal or reuse the printing and the logo and the color scheme and try and make it look like genuine Arduinos. So what clone manufacturers are supposed to do is they're really supposed to call their Arduinos Arduino compatibles, or they can just call them something else. And usually what they do is they call them something that sounds like Arduino, so that when you're looking around for things, you kind of know that it's something like an Arduino because the name is something like Arduino. There's actually one company in China that calls their clones Funduinos, if you can believe it or not. Kind of hokey, but that's what they do. So that's enough about all the naming and the legalese and stuff having to do with the Arduino stuff. So the original Arduino itself is pretty simple as computers go. You'll learn enough to get you going in the labs and the lecture for the course, and even more about it when you take ME16, whenever you get around to taking ME16, or I'm sorry, ME106. So I'm not going to really go into too much detail here about the guts of the Arduino. You'll be getting that in due time. So if you do want to learn more about the Arduino, there are dozens, literally dozens of books that you can get, as well as just a ton of information about the Arduino that's on the internet. It's popular enough that if you Google Arduino and some application that you might want to use the Arduino for, you are extremely likely to find something out there on the internet from somebody who's done something like that project already. So by choosing to use the Arduino here at San Jose State, there are a wealth of resources, free and paid, namely in books and classes and things like that, that you can take regarding the Arduino if you want to learn more, and I really hope you do, because things like this are what, all engineers should be at least familiar with, whether they're electrical engineers, mechanical engineers, and even if they're mechanical engineers, they don't even necessarily have to be mechatronics engineers. They could be thermals people, people doing controls and automation. It's good for quite a few things. So, spend some time, focus on it. It is literally the wave of the future. And programming itself is important in your discipline too, whether you believe it or choose to admit it or not. Programming isn't going to go away. In fact, there's programming in Excel, there's programming in AutoCAD, there's programming in a lot of the design packages out there. And the more you get comfortable with programming, the better off you're going to be in the long term. So I hope that I'm not being too preachy, but you really do need to spend a little bit of time working on it, and I hope you don't despise it. So let's see, books, other materials. Okay, so I'm just going through my notes here. So what I will say is that when you are getting started, that you resist the urge to just kind of wing it. Right away, plug in the board and see what happens. You really do want to get the software for the development environment, the compilers and the editor, and in particular the drivers working correctly when you first start attaching the board to your system. So what I recommend you do, in fact what I strongly encourage you to do, is go to the Arduino website, which is www.arduino.cc, not .com, it's .cc, and click on the download button on the home page, and that's where you start to get going. You'll download the software, and there's a link on there about how to get started. And one of the first things you'll do is probably start installing the driver. And it's not that it's that difficult, but in the past, if you did installation pieces in the wrong order, you had to expend a lot of time and effort trying to undo what you did and get the driver installed correctly. Frankly, I installed mine on my laptop so long ago, I don't know how problematic the installation process is now, but sorry about that. But please follow the instructions pretty much no matter what they are. And if you have a Mac, don't worry, this is actually natively supported on the Mac. And if you're one of the 3 people in the world that's using Linux on your desktop, it actually runs on Linux too, which is one of the pretty cool things about the Arduino environment. It works on pretty much all platforms. So once again, the Arduino is very, very popular, and it's primarily because it's so easy to get started using it. And this is why we've chosen to use it for this course as well as ME106. A lot of other universities use it. Stanford, I've heard, even uses it and have been using it for a couple of years. In fact, we started using it a year or 2 before they did. It's used in a lot of high schools, and it's actually part of deliberately hackable projects and products that are out there because it is so easy to use and very popular that a lot of people do have familiarity with it. A lot of the hobbyist class 3D printers and CNC milling machines and vinyl cutting machines and all sorts of other automated tools have Arduinos in them. So you're likely, if you ever use a computer again, in sort of an embedded package, you're fairly likely to run into an Arduino sitting inside of it. It may not look exactly like this one, it may be a different version, but fundamentally it's an Arduino, and you're going to understand how to program it to some extent by the time you graduate. So congratulations. So due to the success of the Arduino, the original Arduino, which is basically this one here, the Arduino teams come out with a number of other Arduino branded boards, all of which have their own reasons for existing, but this version, the Uno, and its predecessors, which are, you don't see them too many of them in the wild anymore. This is pretty much the main Arduino board. I guess that at least 80% of the sales of all the Arduino teams' 2 different Arduino themed boards are basically this board. And if you count all the clones that are out there, probably 90 plus 95% of all the Arduino boards are basically this board. So this is the one to start with, no doubt. Maybe once you start getting to 106, you'll have a need to use one of the other boards in the series. And if you choose to, you'll find that everything you learned about this Arduino is going to serve you well for using one of the fancy Arduinos in the future. So this board itself is both powered and programmed over USB. So one of the other things in the box is a little USB cable, and I do mean little. It's 12 inches. If you buy a standard regular Arduino, you actually don't get the cable included. So not only do you probably pay twice as much for a genuine Arduino, you don't get the USB cable. So the USB cable is also actually used to pass data, other data, like your data, either characters back and forth across the USB link into a window that you'll learn about in the development environment called the serial console. And you can use it to display messages from your Arduino. Often when you're debugging, they're debug messages to kind of help you figure out where you are. The other way, which you'll learn more about in ME106, is how to use the oscilloscope and some of the other benchtop tools to help you debug your programs. But for the most part, people use print statements, basically, that go back over the serial cable and get displayed on the PC to help them debug their programs. And frankly, it's probably the way that most people do a lot of their debugging. So you'll learn more about that probably. I'm assuming you'll learn about that in ME30. You certainly will in ME106. So what else do we want to talk about here? So there's a a bunch of other connectors on this board. Let me try and zoom in a little bit here. And it's through these connectors on the top and the bottom that are basically going to be used to connect to pretty much everything that you're going to ever connect to your Arduino. The only exception, like I said, is for data. You can transport it across the USB cable. And there's a connector over here, which most people don't use for much, but is there for some specific purposes. And some specific boards actually, like the Ethernet board, which if you want to hook up your board to the Ethernet, you're able to do, and it uses this 6-pin connector that's over on the right. So the idea with these connectors here is that these are female connectors that are used to plug other boards onto the top of. So these are pre-made boards, of which you'll see one in 30 seconds here, that are pre-made so that you don't necessarily have to breadboard everything, or find an Arduino that may be someone's tailored specifically for a particular purpose. So the original plan was always to stack other boards on top using male connectors on the bottom to insert into the female headers that are on this guy. For the most part, you don't really have to worry too much about hardware in this course. It's primarily all software. However, you'll learn more about both hardware and more software in ME106. So you've got that to look forward to. So everything that you're going to be using that interacts with the Arduino this semester is pretty much on this board right here. Let me stick it here. Like I said, it's got the male connectors on the bottom that end up connecting into the Arduino. And over the past, well, these have been around for 5 or 6 years now. We've been pretty much calling this board, especially here at San Jose State, the experimenter board. It's got a lot of stuff on it, and it basically demonstrates a lot of the types of things that the Arduino can be programmed to do really easily with just a little bit of software. The other big idea with designing this board, the way it's done, is that you can use it as a building block for building your own projects or prototypes, either on your own or in your ME106 term project, or any other classes that you may choose to use it in. I don't believe the Arduino has ever been officially used in some of the other MAE classes, but I know that a bunch of people use it in the measurements and instrumentation class. I don't know what the number it is, sorry. But very early on, I think the very first semester we started using the Arduino, people the next semester were already starting to use it for some of their other classes, which is great. And frankly, some of these people struggled with using the Arduino even when they were in 106. And the fact that they felt comfortable enough using it in a course where it wasn't even required was actually really nice vindication that we chose a really good platform for students to use and learn from and use in other projects. So these accessory boards that stack on top of each other like this. So boards that stack on top are called shields. And that's just an artifact of some of the Arduino history, which you can, I'm sure, read about on the Arduino website if you're interested in pursuing it. I don't want to spend too much time on that here. So this board is also often called the experimenter shield. You might hear Brian refer to it as that, or the experimenter board. So on this board there are, I'm not sure how well we're going to be able to zoom. Okay, so this is about as zoomy as we're going to get. So there are 4 LEDs, 4 red LEDs on the board, these kind of white blobs. There are, now let's try and do this in an order that I cover everything. There's a red, green, blue LED up here. It's one LED, but it's actually got 3 sub pieces in it, sub dies that have them all together in one package. And you can use them to blend to make any color you want, including white if you turned all 3 colors on. What else is here? There's 4 momentary push buttons. Momentary in that when you press them, they close, and when you let them go, they spring back. So they're not like toggle switches in that when you press them down, they stick in the other state. They actually pop back to the original state. And that's the difference, basically, if you're shopping for switches, between a toggle switch and a momentary switch. Over here, there's a temperature sensor. Down here, there's a rotary, or what's also called a wheel potentiometer. It's basically a variable resistor. It is exactly the same type of device you used to see on volume knobs on little portable radios. We actually don't use it as a volume type device. We use it as an analog indicator or an analog sensor to indicate a continuum of values. It's basically used as a sensor. What else? There is a piezoelectric kind of toy speaker. It sounds very tinny, but you can generate multiple tones with it. It's not a buzzer that only knows how to make one tone, annoyingly. And there is a 3-pin header up here, which is used to connect hobby servos, either micro or mini servos. Nothing that takes an obscene amount of power, but you know, a little hobby servo like this, or the next larger size, which tends to be about maybe 2.5 inches by an inch. That's about the largest servo you're going to be able to drive with power directly from this board. And in the middle of the board, there's this little slide switch here. It's a 2-position slide switch, and it's used for choosing between using the 4 red LEDs or the red, green, blue LED at any one point in time. Because there would be so many LEDs otherwise, consuming a lot of the pin resources on this board, we allow you to only choose to use one set at a time because it frees up pins to attach lots of other things to. So there's on this board, you'll notice that there's a couple of empty spots for some other optional devices. These are, when installed, these are actually the difference between the standard kit and the deluxe kit. There's a spot over here and a spot here and another spot down here, which you'll learn more about in the other videos or video. So this board also, like the Arduino board on the bottom, it replicates the female headers up here. And the idea is that theoretically you could plug another board on top of this board, but it's not really what this board was primarily designed to do, because if you think about it, what if you put another board on top of this? Well, you can't get at anything on this board. So except for the next board that you'll see, you're not really intending to plug anything into the top of the board, at least as far as a shield is concerned. What you will do is you may be plugging in wire jumpers that jump out to a breadboard, which you'll do all your prototyping on for your ME106 projects and for whatever else you happen to be playing with at the time. And that's where a lot of your work is going to get done. However, most of the time for projects, you always need, 1 or 2 buttons or more, a couple of LEDs. You might want a speaker for alerting. And that's the whole reason behind this board, is that a lot of these things are already on this board, and it's less stuff you have to put on a prototyping board. So it saves you time and space, and believe me, a lot of aggravation. Once you start wiring things up on a proto board, you start ending up with a pile of spaghetti. And anything you can do to minimize that spaghetti, namely using things that are on this board, is going to save you a lot of time and aggravation when you're putting together your projects. One thing I forgot to mention is there is a light sensor down here, this kind of oval-shaped guy at the bottom, and he can be used to detect light levels. So he can easily discern the difference between light and dark, full daylight, something breaking a light beam, for instance, or just generally you might choose to tailor the intensity of the LEDs depending on the ambient brightness. So those are some of the many uses for an ambient light sensor. Every cell phone, every smartphone's got one, right? Saving power, not driving the display at least as bright as you need to when you don't need to, saves yourself a heck of a lot of power. And every smartphone has an ambient light sensor, whether you know it or not. It's lurking behind the charcoal-covered glass somewhere on your phone. So Let me get a drink here. So the board also has labels on it. A little bit hard to see here, but once you get your board and look at it, there are abbreviations for what's connected to each pin on this board. So you don't have to go and find a reference sheet that reminds you about what pin numbers are connected to which elements on the board. You can read them right off the board, and I think that's a pretty big convenience. And if that means nothing to you, it will in a week or two. As you start programming, you'll understand why knowing which pins are connected to what is so very, very important. So the last board that's in this stack is this board, and it's an odd shape, and you'll see why soon. And this is called the Pew Pew board. You will find out soon why it's called the Pew Pew board. In fact, it'll be the last little demo I do here in hopefully the next few minutes. And it is designed in such a way, I have a blank one right here, that one of these little micro servos slots in and holds it, so you don't have to have some other housing or mounting that holds your servo. Keep it from walking away from you. And a connection for a laser, and this one's already got the laser soldered into it. So what you end up with is a servo that is hot glued to this board and a laser pointer that is hot glued to the top of the servo. And programmatically you can cause the servo to move and therefore spin the laser and move the laser around. And if this sounds to you like a sentry gun, that's exactly what you're going to be doing here in the next few weeks. So you'll see exactly what this looks like in a few moments, and it's pretty funny. So I did mention that these guys are hot glued together. This is a feature and not a bug, although occasionally it may seem like a bug. So the idea is that when you're all done with this course and the cuteness has run out of the Pew Pew board for you, you can pop off the laser. It's hot glue, so it will kind of break right off. You do have to be gentle. And you can do the same thing with the servo. So you can use the laser and servo in other projects. Alternatively, you can actually keep your board intact. If you don't want it or those two parts, you can always sell it to somebody next semester. Some of you may have inherited parts of this stack from friends that have taken this course in the past semesters, and you're more than welcome to use them for this course. If you've got a full set of stuff from somebody else, you're all set. You don't need to buy a kit. So the downside of constructing the Pew Pew board here with hot glue is that it's semi-easy to to shear this laser off of the top of the servo motor. So if this happens to you, if you don't already have a hot gun, it's probably tool number one in importance. I think for mechanical engineers, between that and a pair of box cutters, you should have both of them. You can either go out and get yourself a hot glue gun if you don't have one already and glue it back on, or you can just rubber band it on. But I would do one or the other, and I would encourage you for $10, just go out to Michael's or even less on Amazon and get yourself a hot glue gun, because it is a really handy prototyping tool for doing a lot of things. So $10 or less, they're cheap. So you really ought to have one. So one fairly important thing that I need to mention is how you should handle these boards, and there's actually two parts to this discussion. First is basically how you're supposed to handle any electronic boards. You've probably seen me do this a little bit already, but even though most commercial printed circuit boards made in the last decade use lead-free solder, not all of these boards that I've made for you are entirely lead-free solder. Some portions of the board use leaded solder. The same is actually true of commercial boards that were made 10 or 15 years ago. A lot of them contain leaded solder. So I was hoping to go completely to lead-free this semester, but unfortunately I found that I wasn't able to solder everything lead-free. And the reason for this is lead-free solder actually requires about a 50 degrees extra heat to solder with, and some of the equipment I have is not capable of going to those higher temperatures. So I actually have to mod some of my equipment to see if I can get it to solder lead-free solder, and hopefully I'll get this done next semester, or maybe not, but we're going to try. So the takeaway here is assume that you're always handling boards with lead in them, because you may not know how old something that you're handling is, and wash your hands after using them. If you've got other people, like family members, that are going to be handling your your Arduino and your Pew Pew boards, if you've got a younger brother or sister that's playing with it, make sure they wash their hands after they're done using them. So just like I said, assume that the boards are nasty and wash up afterwards. The 106 lab has a sink in it. I don't think the ME30 room does, but try and get in the habit of leaving the class and going to wash your hands before you head off to your next class when you leave, like your ME30 lab. So the other point about handling the kit is that taking these boards apart is sometimes a non-trivial task. In fact, my philosophy is always, unless you really need to separate the boards, leave them together. Don't plug them in and unplug them every time you use them. There's no reason to do that. And don't plug and unplug them any more than necessary. And the reason for this is that because there's just so many pins on this board, there's actually 10 plus 8 plus 8 plus 6, 32. I can do math. There's 32 pins joining this board with this board, and the sum of the friction of all these long pins and the connectors inside of these females really makes it difficult to get these boards apart, especially if they use these long flavored headers like is on this board. The Pew Pew board you'll actually see has shorter pins on them, and they're, I would say, substantially easier to get out, but these two things can be a bear to separate. So it's really easy to bend these pins when taking them apart, and straightening the pins to get them straight again is extremely difficult. I mean, basically they're plastically deformed. Metal never goes back to the way it was when it was manufactured. So every time you bend a pin and try and straighten out, it's not going to be perfect. And then every time you plug the board in and take it out and plug it in and take it out, it's basically reaming out the connector, the interior of these female connectors, and it's going to wear these things out, and eventually they're going to get to the point where they won't make good contact with the boards you're plugging in above them. And at that point, the board gets to be fairly useless. If you're trying to use a pin in a board and it's not making good contact, unless you've got another pin you can use, you almost might as well ditch the board. The good news is Arduinos are really cheap, and they're getting even cheaper. So for 12 bucks, whatever, 15, 10, 8, 16, whatever, don't cry about it. It's not the end of the world if you do end up wearing out an Arduino. So once again, if you don't have a good reason to take them apart, don't. In fact, I'd go so far as to say that you shouldn't even remove the experimenter shield from the Arduino until the semester's over. And there's no reason to do it till then. In fact, you could probably get by through 106 just leaving your experimenter board on also. And part of the reason for this is that for everything that's on this board, you can actually disconnect it from the Arduino by lifting these jumpers. It's going to be hard to tell here in this lousy light, but these are these little jumpers that you're used to seeing maybe on disk drives, if you've ever put a disk drive in your machine, and they cover up these pair of prongs. And what you can do is, if you want to use a pin that is already being used for something else, like say you've got a project and you only need 2 buttons, and you want to use the pins over here that these 2 buttons are connected to, you can disconnect them by pulling the jumpers on them, and that frees up connecting whatever else you want to these pins. So there's really nothing that you can't get at on this board that you can't get at on this board, even with this thing connected. In fact, there's a little hole in this board that allows you to see through to the LEDs on the bottom, which is really handy because these things will sometimes flash during programming. And you can look right down through the top board to see those things on the bottom. So like I said, there's almost no reason to take this thing off once you get it. And I'd recommend leaving it on as long as you can. In fact, you may just want to leave them together forever and just get another Arduino at whatever point you want to make another project, because they are cheap. So the only exception to the rule of not removing any boards any sooner than you need to is actually the Pew Pew board. And it has been designed to be especially easy to remove because, if you'll note, not all the pins are soldered into all of the holes that could be soldered into. And I also use these short header connectors. So this has the dual benefit of minimizing the number of pins that you actually need, and therefore lessens the amount of friction between the boards that you're trying to separate. And the shortness of the pins also decreases the amount of friction. So this is kind of a win-win. So this board was actually designed to be easily removable. In fact, I would say, because you're not going to use this board, the Pew Pew board, for a few weeks, I would actually, once you get it home, go ahead and take the Pew Pew board off the top and stick it away in a safe place where the pins aren't going to get bent, you know, away from the dogs and the cats and the kids and brothers and sisters and whoever. And then you just go ahead and put it back on when you need it, and when it's time to do that lab in week 3 or week 4 of Arduino programming. So I'll show you momentarily on how to take the boards off. But this is the exception to the rule of leave boards on longer, as long as you can. So what else? If you'll notice, this is a shield, right? It qualifies as a shield. It plugs into these Arduino connectors, but it's designed in such a way that it doesn't block access to anything that's on this board, even the temperature sensor and stuff that's over here on the edge. This is actually, I'm pretty happy with this design. The first design that we used up until about 1.5 years ago was pretty flimsy, pretty ugly, and even though the board was a lot smaller and therefore cheaper to make, it wasn't very robust, and some people broke theirs, and it took me a little while to figure out what I was going to do about it, but this is the end result, and I actually think this is pretty cool, if I do say so myself. So okay, so I think we are going to go ahead and start doing the board separation ritual. So, okay. Like I said, especially with this board, when it's joined with this board, there is a huge amount of friction that exists between those 30-some pins between the two boards. So, like I said, it's especially true because it's got these long headers on them. And boards usually have long headers on them if they also have these female headers on top. If you notice, the Pew Pew board doesn't have any female headers on top because we don't anticipate that you're ever going to need to plug anything into these. So this is kind of a terminal top board. So, so the big problem is that when you try and take these things apart, unless you take them apart and they're perfectly parallel with each other, what's going to happen is as you pull these things out with some force, inevitably the board is going to come off like this, or more commonly like this or like this. And what's going to happen is you're going to bend, especially these corner pins. These 1, 2 corner pins are really prone to bending. So, like I said, don't do it unless you need to, but you're gonna, at some point, you're gonna need to take apart other boards. If not this one, then some other ones, and learning how to do it right is gonna help. So let's go ahead and do this now. So the general idea here is to take the two boards, and what I do is I actually press my fingers against the edges of the board, and I touch my fingertips together. And I'm pressing down on the edges, the board edges, really hard. And then what I do is I push my fingers together, and I use the force that's actually kind of diagonal. Oops. It's actually kind of diagonal to pull the boards apart. And the idea is to basically do this as slowly as possible. Speed here is not your friend. Speed is your anti-friend. So the idea is to take, this was very easy. The idea was to take as little, is basically to move these, to pull these pins out as little as possible off of one side and then turn it over and do the same thing with this one. And you're really only looking to move these things about 1 millimeter each time you do this. So 1 millimeter, another one here. And the goal, like I said, is to try and keep these boards parallel so that you don't end up skewing any of the pins. And you do this over and over again until you get your boards apart. Now this board is especially difficult. It's extra difficult because it's brand new and so it hasn't loosened up at all. And the problem is my hands are a little bit sweaty too, so it shouldn't normally go quite this slowly, but you do want to take your time. And actually my hands are too sweaty to do this. There we go. And the goal is to get the pins out far enough that most of the resistance goes away because the body of the pins doesn't overlap very much. And so the last separation should actually only be for a couple of millimeters. So not so bad, right? No bending. So never thought of it, but make sure your hands are dry. And that's it. That's how to take apart a board. I would practice on the Pew Pew board first just to get the feel of how to position your fingers on the board edge and using them to pull the boards apart by using the opposing force on your fingertips. So try it with this one first, and you should at some point be able to take off your experimenter board or other shields maybe that you buy for other purposes with other Arduinos. So putting them back together is it's easier. What you generally want to do is you want to pick one side, and I just lay the tips of the pins in the hole. Don't push them down at all. And then I rock the other side down. And then what I do is you just put them in enough to just stick together, basically under its own weight. And then what you do is you look at the end of the board to make sure that none of these pins are skewed out either inside or outside of these headers. Now I can see here that I've got all the pins, I think, in the right places, and I'm going to give it a little push here. Just to get it in a little bit farther, I'm going to look again, and it looks good, and then I'm just going to basically push them the rest of the way together. So the only thing you really have to be cognizant of is there's a gap between the top headers and the bottom headers, and you just need to make sure that the gap of the board you're plugging in corresponds to the gap in the females on the bottom. And that's basically all it takes to stick together boards. And same thing with the Pew Pew, put one side in, and then the other side. And sometimes what will happen is that maybe some of the headers will get slightly displaced. If it doesn't work in one direction, try the other one. And see, that one just went easily. There you go, your boards are back together again. I can't emphasize enough, be extremely gentle. Work the boards apart as little as possible. The goal should be to take lots of turns doing this and this and this rather than trying to minimize them. I guarantee you it's going to help preserve the life of your board. So what else do I want to cover here? Mention the gaps. Okay, I guess we're ready to do the demos. So I don't remember, I programmed each board differently and I don't remember which board is which. I think this is the second board. So let me plug this guy back into here, put that there, make sure, push it in a little bit, still good, push it in all the way. Pew Pew board. Gotta get the cables out of the way. A little annoying, but if somebody else comes up with a better wire management scheme than this, let me know. I'm happy to take feedback about how these things are built. how they might be improved. Okay, so let's see if this is the board that I think it is. So it may not be obvious, but these servos have a range of motion. So technically, most servos aren't guaranteed to go 180 degrees. A lot of people think that that's kind of the standard range of motion for a servo, but a lot of them are only documented to go 45 degrees each way, or maybe 60 degrees each way. Some end up working a full 180 degrees. It turns out these black servos here don't go a full 180 degrees. So if you find yourself trying to move one programmatically to 0 degrees and it gets stuck, you'll know what happens. Sometimes all you need to do is just give it a little nudge, and it'll come back into position if you reset it to be 90 degrees. So when assembling these things, I had to find the center point of the servo. So I programmed it to basically be 90 degrees straight ahead. And then I hot glued the laser pointer on top of the servo, so that when you direct the servo to point straight ahead, it actually points straight ahead. So if you break yours off, write a quick program to just center the servo to 90 degrees, and then unplug it, and then hot glue your laser so that it's pointing straight forward at the last position you left the laser. So one thing's a little deceiving here is you'll see this one is pointed kind of wonky, and it's just the way that it was unplugged the last time. It actually kind of does a random reset when it powers up, and that happened to be the last position it was in. But normally if you write a program to set it at 90 and unplug it, it'll stay there. One thing I forgot to mention is always when connecting and disconnecting boards, or even sticking wires in these little holes, turn off power to your board. And the only way really to turn off power to the board is to unplug the USB cable. Don't connect live powered boards together. A lot of boards will actually survive it. It turns out when you plug a servo in, it actually will reset or hang the processor. So you'll need to unplug it and plug it back in manually. If you try and connect something like a servo to it. Other things you don't have to, but I got to tell you, I've only fried 2 Arduinos in 7 years, and one of them I fried while I was trying to slip a wire into one of these holes because I was trying to wire up something on a breadboard, and I missed, and I touched the bottom board of the Arduino and I toasted it, and it never worked again. So that was a painful lesson. No, it wasn't that painful, but it was an annoying lesson to learn, and I'm passing it on to you. Save yourself, well, in a pinch, you may have to go to Fry's and pay $25 for an Arduino, but save yourself 25 bucks or 15 bucks or whatever, and don't plug anything into a live board. Okay, so let's see if I've got the right demo here running on the right machine. Hey, it's USB. It's never supposed to plug in the right way. Okay, so what's going on here is that I am running a test program that I designed and run on every board that I make to ensure that everything works. And every board that you'll be receiving, unless I forgot and accidentally left the other demo on, will be running this program, and you'll be able to tell because it'll flash the 2 red LEDs like this, or if I left the slide switch in the other position, it'll actually go back and forth between red and green. So I try and also leave the switch when I stash it away in the box for you guys in this position. So this is just an indication. How am I going to do this? So this program, when it runs, it actually prompts me to go through a series of steps to do the right things in the right order to test all the components on the board. And I don't know if I can show you this live or not. I guess I'm not going to try. Otherwise I have to take the webcam off the tripod, and that's going to be annoying. So you're just going to have to trust me that I am following along with the prompts, and I will tell you what I'm doing as I do it. But the first prompt is that this program was actually designed to work on every version of every board I've ever made. And so this is prompting me to tell the program whether it's an old board or a new board. And a new board is anything that's version 4.1 or greater. Everything that you guys are going to be getting is 4.2 or 4.3 boards. So it's telling me to tell it that it's a new board. So I press it, and the next prompt is asking me to light every of the 4 LEDs by pressing each of the 4 buttons. So if I go through in any order and I press all 4 buttons, all 4 LEDs should work. This proves that the 4 switches work and that the 4 red LEDs work. The next thing it's telling me to do is to switch the jumper to the red, green, blue position over here, and then press any of these buttons to continue on. And it flashes through red, green, and blue there, and that tests to make sure that all 3 of the sub-LEDs and that red, green, blue LED are actually working, and all the connections to them are intact on the board. Now the next thing it's asking me to do is to rotate my wheel potentiometer over its full range, and it says, oh, you have a potentiometer. And if I had the part that was in here, I would also be asked to rotate it, but since I don't have it, I can't. And then I press the button here, and it does a little servo self-test. As you saw, it actually swung it over a range. It's probably about 60 degrees or 45 degrees each direction. That shows that the servo's functioning and that all the connections to the servo are functioning. Now what it's doing is it's running a program that varies the brightness of the red, green, blue LED depending on how much light is falling on the light sensor. And if I make the light sensor go dark, it says, oh, well, I need to compensate by making the world lighter. And if you take your finger off, it darkens the LED. So it's kind of like a nightlight. It does the opposite of what it's seeing. If I'm in a dark room, turn on the light. If I'm in a light room, don't bother, because I can find my way around. And then I press a button to show that I'm done with that test. Oops, press it again. Now it's telling me to put my finger on the temperature sensor, and as I do this, it's actually programmed to say that the hotter it gets, that the redder the LED here gets. And if I take my finger off of it, no rats, I don't have my canned air. Usually I will spray canned air on the temperature sensor, and it'll go blue as it goes below ambient temperature. But I can't show you that to you here, but I can kind of wave it and at least get the red to go away. And that test is done, so I press another button. It plays that little tune. That proves that the speaker's working. And then it says, go ahead and press the reset button, which is in the bottom left-hand corner, and I press that. And the board resets, and it goes back to its initial condition of asking me which version of the board is connected. And that is the self-test. You will have access to the source for this thing. You can either find it maybe on the homepage for the YouTube channel, or Brian or I will let you know where it is for you to download. And the primary purpose is more for you to use as a basis of checking to make sure your board is okay. You as a beginning Arduino programmer are going to be making mistakes when programming, and you're going to wonder whether your hardware is working or not. You're going to swear that you've programmed it correctly, and then damn it, it must be the board. But as a beginner, it's probably not the board. It might be the board, because this is hardware that you actually move and beat around. But if you were programming on a PC, you're going to swear, oh, I know I'm programming it right. The PC, something's wrong with the PC. Well, it's usually you. Deal with it. I mean, let's face it. So if you ever have any doubts as to whether your board is intact, go ahead and compile and run the test program and run through it. And maybe I'll have a video demonstrating how this interaction works separately. Keep your eye on the YouTube channel. So that's it. That's it for the board demo. So now I'm going to show you the fun demo. And to do that, just unplug this guy. Now what this is basically the program that you're going to be writing if the semester is like most of the last semesters on the last week of your lab to, let me set up here, to use the Pew Pew board. And just for demonstration purposes. And you can see I can use these. I can use the 2 buttons here. Let's see if I can zoom out. So what you do is you use the 2 buttons on the ends, and you could actually program it to use the wheel thing here, right? It goes left and right. You could use it to steer the servo also. I have a button in my program to actually center the servo. That's how I know how to hot glue it, is I center the servo before I hot glue it. And so, and then, oh, surprise, look at that. So it makes a noise. You can shoot at stuff, aliens, brothers and sisters, the cat loves it. And this is what you're going to be learning how to program for the rest of the semester. So I hope you understand now why it's called the Pew Pew board, because it makes the pew pew noise. So that's it. This video has gone on a lot longer than I thought. I was thinking it would be about 15 minutes, and instead it's an hour. Sorry about that. Unfortunately, like I said, there's another video out there that is going to be describing the differences between the three kits. It should go pretty quickly. I've pretty much described everything about the kit that you need to know except for what the differences are. So that one should be pretty quick. I guess if I had to do it all over again, I would suggest maybe you look at that one first, so you don't have to suffer through an hour of this. But you do really need to watch that. So when you come to me next week or the week after or whenever you get around to buying your kit, that you know what you want and you know what to ask me for. And it'll also discuss what the prices are. And the price variance between the kits isn't very great. So that's it. I hope you enjoyed this video, and I apologize for it going on so long, but it's actually pretty cool. So I hope you enjoy playing around with this thing as much as past students have and as I always have. I hope you get a lot of good fun and value out of the kit. So that's it. Take it easy. Bye.